Hi everyone, welcome to Analytical Lab. Today we are going to do experiment 6, which is silver ion selective electrodes in equilibrium. And I'm going to start today by preparing my electrodes. So what I have here is I have 2 silver wires, they're very fine. And I'm just going to start by buffing them a little bit with some emery paper here just to remove anything that might be on the surface. And then I've got both wires attached to a 9-volt battery. And I'm going to put both ends of these in this vial of 0.5 molar hydrochloric acid. And what I should see happen here is that at the cathode, so the end that's attached to the negative end of the battery, I should see some hydrogen gas evolved. And then at the other end, at the anode, what I should see is that I'm going to deposit some silver chloride on the wire. And so the silver chloride is going to be my reference electrode in this case. And so I'm going to hold this in the solution for about a minute. So once I pull these out of solution here, what I can see here is that one of my wires is now a blackish gray color. That's the silver chloride coating on there. And the other one is still a nice shiny silver wire. And so I'm going to go ahead and just coat these a little bit more, and then I'll take some pictures as well to put them in there so you can see the difference. The wire in the front is attached to the cathode. That's where the hydrogen gas is forming. The wire in the back is where the silver chloride is depositing. So now that I've got my reference electrode wire prepared, I'm going to go ahead and work on setting up my electrochemical cell. Now that I have my wires coated, I'm going to set up my electrochemical cell. So I'm going to take my silver chloride coated wire and I'm going to put it in one of the glass tubes in this apparatus. It's just 2 glass tubes through a rubber stopper. And I don't want it to go all the way down to the bottom, but pretty close. And then I'm going to use an O-ring here to just hold this in place. And now I'm going to take a fine piece of thread and I'm going to just kind of make it a little bit thinner than it currently is. And then I'm going to put it in the opposite end of that same tube that has my silver chloride coated wire in it. And I'm going to put a stopper on the end and make sure that this is really well sealed. So this is going to be my reference electrode compartment. So I want it to be pretty well isolated from the rest of the system. And then I need this string as a liquid junction so that I don't end up with any potential differences there from charge imbalance essentially. And so once I think that that's pretty tight, I'll go ahead and I'll put my bare silver wire in the other tube now. So this will be what's called my working electrode. And I want this again to go pretty close down to the bottom, but not all the way. I want it to get pretty close to the opening there. And then again, I will put an O-ring right there on the end to hold that wire in place. So now my general electrodes are set up. I just need to get the solutions ready to go. So the last step in getting this set up before I start making any measurements is that I'm going to add a 0.01 molar ammonium chloride filling solution to my reference electrode compartment. I'm going to fill it pretty well up there so that the silver chloride portion of that wire is submerged. There, that looks like enough. And I just want to take a look at this seal down here and make sure that it's not leaking. If my reference electrode compartment is leaking, then I'm going to end up with some unstable potentials as I make my measurements. So this looks like it's pretty good. So now I'm going to put my beaker underneath here, and this is what I'm going to do all of my measurements in. So I'm going to then take my 100 milliliters of diluted silver nitrate ammonium nitrate solution that I just made up, and I'm going to pour it into my beaker here. Now I need to lower my electrode setup into the beaker. And I'm going to put it off to the side here because while I'm making my measurements, I want to be stirring. I've got a little magnetic stir bar in there. I'm going to turn it on. I don't want it too high, but I also want to make sure I'm getting some good mixing. So usually about 200 RPMs is really good there. And so now what I'm going to do is I'm going to hook up a digital voltmeter to my electrode setup here. So I've got my digital voltmeter and I'm going to set this to read potential in millivolts. So my initial E cell is fluctuating right around 146 millivolts with nothing except the initial silver solution added. So I just added 0.01 molar ammonium chloride to this solution, and we can see now that it's fairly cloudy where it was very clear before, and we can see that our E cell has dropped as well. And so what I'm going to do is wait a full 10 minutes before I take my E cell reading, because you can see it's still changing right now, it's still dropping. And that's because there's a difference between fresh silver chloride colloid and some that's had some time to age. So for consistency for all of our measurements today, we're going to wait 10 minutes. All right, so it's been 10 minutes since I added the ammonium chloride solution. And my potential reading, my E cell, has stabilized at about 47 millivolts. I'm going to go ahead and record that. And some of you might be wondering, a decimal place here, why am I dropping that? And so if you think about how much that last decimal place is fluctuating, the uncertainty in that place is so great that it's actually better for us to go to the nearest whole millivolt whenever we're making this type of measurement. And so I'm fluctuating right around 47, so that's what I'm going to call that. My next step now is I'm going to add 3 separate aliquots of ammonia and ammonium nitrate solution. And so I'm going to add 10 milliliters each time, and between each addition I'm going to wait 10 minutes before I read the E cell again. So when I go ahead and add this aliquot, what I see is here the solution is no longer cloudy, it's cleared back up, which tells me that I no longer have silver chloride present here, okay? And if you check out the E cell is dropping again. So I went from 47, now I'm all the way down under 30 millivolts. So one of the things that you should think about while we're waiting our next 10 minutes is, why is the potential dropping? So think about the relationship between E cell and silver ion concentration, and think about what must be happening in this beaker with every addition I have. All right, it's been 10 minutes since our first addition of ammonia and ammonium nitrate solution, and we can see that the cell potential is fluctuating right around negative 15 millivolts. So I'm going to go ahead and record that for us. And the negative there isn't actually an issue. So think about, as we go through the next few, what does that negative sign actually mean here? And what I'm going to do now is get ready to add my second 10 milliliter aliquot of ammonia and ammonium nitrate solution. So I'm just measuring that right now. All right, so here's our second aliquot of ammonia and ammonium nitrate solution. And we can see that as I'm adding it, the solution is remaining clear and the cell potential is changing again. And so what we're going to do now is we're going to wait another 10 minutes and then come back and read that E cell again. All right, so we're back to take the E cell reading after our second addition of ammonia and ammonium nitrate. And so it looks like we're hovering right around negative 33 millivolts. So I'll go ahead and record that. Now I'm going to add our third and final addition of the ammonia solution. And then, surprise, we'll wait another 10 minutes. So here we go. Last 10 milliliters of ammonia solution are going in right now. And again, the solution is still clear here. And we're seeing that we're getting a potential change. And so as soon as I get all of this added, we'll wait our next 10 minutes as well. All right, it's been 10 minutes since our last addition of the ammonia and ammonium nitrate solution. And we are now hovering at an E cell of negative 45 millivolts. So our last addition here is going to be the addition of 10 milliliters of potassium iodide solution. So I'm getting that ready to add right now. And then we'll wait another 10 minutes after that addition and take one final E-cell reading. All right, so here is our 10 milliliters of 0.01 molar potassium iodide solution that I'm adding right now. And hopefully you can see it on the video, but now the solution is starting to turn much more yellow than it was before. So let me put some white paper behind it here to hopefully help see the yellow tint. If not, just take my word for it. The solution is now yellow, which indicates that we have some silver iodide present. All right, so we're back for our last E-cell measurement after adding the potassium iodide solution, and it looks like it has settled in at around negative 211 millivolts. And that is our last E-cell reading that we need. So now what I'm going to do is I'm going to move and disconnect the electrochemical cell. And the last thing that we need to do in this experiment is we need to determine the concentration of ammonia that was in the solution. And so the easiest way to do this is by titration with hydrochloric acid after the fact. So what we're going to do is add a few drops of bromocressyl green indicator, which is blue under basic conditions and yellow under acidic conditions. So we'll add about 4 or 5 drops, I think, to get it nice and blue there. I'll turn up my stir speed here just to get it nice and homogeneous. So we've got a nice blue color here indicating that it's basic, which is what we expect based on the fact that there's mostly ammonia right in that solution now. And I've got a burette set up with 0.457 molar hydrochloric acid. I standardized it before we got started. And my initial burette reading right now is at 13.00 milliliters. And I'm just going to slowly titrate this until we get a color change from blue to yellow. So we'll add a little bit at a time. So I'm expecting that this will come in somewhere between 15 and 30 milliliters based on the concentration that I started with of ammonia. But I'll still go pretty slowly because the ammonia gases out as it sits here in contact with the air. There we go. So there's the end point here of our titration, and this is at 30.80 milliliters. So 30.80 milliliters is our final volume on our burette, and 13 was our original. So that looks like we're at about 17.8 milliliters total. And so what we'll do now is end the experimental portion of this lab, and we will work through the calculations in the lab part when we have our live Zoom session. I hope you're all taking good care of yourselves. Get some rest, wash your hands, take a break, and let us know if you have any questions or you need anything. Have a good day, guys.